Let us now look at problem 2. So problem 2 follows similar principles based on problem A, although it was problem 1, although this is a slightly different problem. Okay, the problem says determine the magnitude and the sense or direction of the current in the 10 ohm resistor when the current I is given to you to be 1.8 amperes. So as you can see from the circuit, you got a 50 volt battery, you got a 30 volt battery, you got a resistor R whose value we do not know, you got a 20 ohm resistor, you got a 10 ohm resistor, and we are required to find the value of the current through the 10 ohm resistor. Now there are different ways of doing the problem, but this is what I proceeded to do. So we are given that the current here is I, the current through the 20 ohm resistor is I. So I assume that the current traveling in this branch of the circuit is some I1. So you got this I1, a current of so much appearing at this junction. And first of all, actually I proceeded by labeling the junction. So you can give it whatever labels you want, but this is what I gave. I called this A, B, C, and D. Right? And so this is, you have this current of I1 coming here, and then you have a current of I leaving through this 20 ohm resistor. So which means that there should also be some other current flowing through this branch, which I shall call I2. And then, so this current I2 traverses to the 30 volt battery, and then proceeds to this loop. It goes to C and then to B. And then if you look at this junction, the junction B, you got a current I entering this junction B, and then you got another current I2 entering this junction B, and then you have a current I1 that leaves the junction B. So which means that according to Kirchhoff's law, your I1 should be equal to I plus I2. Right? Simple Kirchhoff law. Whatever current that comes in must be equal to the current that goes out. So which means that your I1 has got to be, another way of writing the same thing is that I1 has got to be equal to 1.8 amperes plus I2. I'm suppressing the units here just so it is not as confusing. So, but everything is in standard units. So now what is my job? I need to find out the value of my current I2. Right? So how do you do this? So there are several ways of doing this problem. So, and this is what I proceeded to do. I use the Kirchhoff's voltage law, which says that if you start from a certain point and then go through a loop and then come back to the same point, the potential difference that you will see should be 0. So I considered this loop. So I considered the loop A, B, C, D, A. So I start from A and then back to A. So potential difference should be 0. So why don't you work with me? Let's go ahead, A, B, C, D, A. So when I go from A to B first, what's the first thing I see? You're right. So I see the 20 ohm resistor. And on the 20 ohm resistor, am I traveling in the direction of the current or opposite to the direction of the current? Right? Yes. Yeah, you're right. So as you can see, I'm traveling in the direction of the current. So what do? I lose potential because I'm traveling in the direction of the current. And how much potential do I lose? Well, Ohm's law tells us that you got a 20 ohm resistor and a current I. So I lose 20 times I, so many volts, right? So minus 20 times I, that's the potential I lose. And then what's the next thing I see? I see this 50 volt battery. Am I going from the negative to the positive or positive to the negative? You're right. I'm going from the negative to the positive, which means that I should be gaining potential. Good. So plus 50 volts. I'm suppressing the units. Okay, and then what's the next thing I see? I see this 30 volt battery, and on the 30 volt battery, am I going positive to negative or negative to positive? Yes, you're right. So again, you're right. See, you guys are brilliant. So I'm going from the positive to the negative, which means that I'm actually losing 30 volts. So let me write down minus 30. And finally, what's the thing I see? So I see this 10 ohm resistor before I come back to A. Through this 10 ohm resistor, am I traveling in the direction of the current or opposite to the direction of the current? Again, you are right. I'm traveling opposite to the direction of the current, right? Because the current I2. So remember, we are going from D to A, right? A, B, C, D, A. I'm going D to A, but the current is actually going A to D. So I'm traveling opposite to the direction of the current, which means that I gain potential. How much potential? Well, 10 ohms multiplied by I2. So I'm going to write plus 10 times I2, and this value has got to be equal to 0 because I'm coming back to A, so I should neither gain potential nor lose potential. Okay, so that's my, and remember, we know the value of I. I is given to you to be 1.8 amperes. So now that's all the physics. Now the rest of it is algebra. So we need to use algebra to solve for the value of the current I2. So minus 20 times I, and we know that the value of the current I is 1.8 amperes. So 20 times 1.8 is 36. So this expression becomes minus 36 plus 50 minus 30 plus 10 times I2 is equal to 0. Right? You following me? If not, feel free to pause the video, go back and listen to it again. Alright, so if you simplify this, minus 36 plus 50 is 14, and 14 minus 30 is negative 16. Right, so I have negative 16 plus 10 times I2 being equal to 0. So which means that if you solve for this, you get the value for your current I2 being 1.6 amperes. Also, another thing to note, so we note that the value of the current I2 we are getting is actually a positive number, which means that our assumption that the current is going from A to D is indeed correct, right? So the current through the 10 ohm resistor is 1.6 amperes from right to left in this direction, right? So which means that your correct choice is A.